Right, so in today's lecture, we're going to hit on lecture 3, which is centered on networks. So I'm going to introduce to you the computer networks. I think there are some basic things that you already know. Anytime we talk about data communication, of course, data cannot be transferred from one point to the other. It needs to pass through a medium. We should have a sender, we should have a message, we should have the recipients, the channel through which the message will pass through, and the protocol. For all these to happen, we need to have something we call a network. So network is very essential in data communication. Now, at the end of this lecture, these are going to be the learning outcomes. So lecture 3 or chapter 3 is going to give you an in-depth of the computer network, as well as the various technologies that exist in computer networks. And most of these technologies support network engineers in deploying and also managing the network. Now, these are the learning outcomes for this particular lecture. So you will have some understanding of the concepts of the computer networks. You would have some knowledge about network topologies. You should be able to identify the key components of any computer networks. And finally, you would be able to describe the characteristics of a network architecture in terms of reliability, performance, and also security. Now, let's move straight to the overview of the computer network. So generally in computing, networking is vital. And the reason is for devices to connect, to be able to share resources and information, there should be a network. So from small local area network through to the large area network, which we normally term as the WAN, connecting devices in building can move from the basic local area network to a wide area network. And in so doing, for the wide area network, most times we are linking countries. So these networks play a pivotal role in enabling communication. So without a network, there would not be any form of communication happening. Per our last lecture, I remember telling you that whenever we think of computer network or networking, the key reason for networking is to share resources. So the idea is to share resources. For instance, if I'm connected to, I have some connection to like Felix in the class, for instance, or Felix has a connection to me, there is a high probability when he needs something, he can ask me based on the fact that he knows I'll be able to deliver. So for instance, if Felix wants a recommendation letter, for instance, he gets in touch with me because he is linked to me and he knows I'll be able to share that resource, which is a recommendation letter for him in cases where he's applying for maybe a degree program or a master's program. So basically, networking is very key. It's very important. If we say somebody is highly connected, and it means the ability of getting virtually everything that he needs because he has linkages with so many people. Now, the operation of network itself relies on key protocols, which we talked about the last time, TCP, IP, which is the transmission control protocol, and IP standing for internet protocol. Please, if you have any question, just raise your hand, I'll give you access. I teach different networking courses, so sometimes I assume you know certain things. So if you don't understand anything, just let me know by raising your hand. I'll give you access. Then you let me know. Right. So as I was saying, the operations of networks rely on the key protocol, which is the TCP/IP, and this helps in seamless internet connectivity, and also another protocol which we normally use in networking is a HTTP, which is a hypertext transfer protocol for web browsing. So generally, networks always prioritize security using techniques like encryption and other data protection algorithm to protect messages that are being sent from the recipients to the from the sender to the recipient. So in today's era, computer networks have become so essential uh, for businesses, government agencies, educational institutions. And by this, it makes it hard to for the data that is going to be transferred from one point to the other to be hacked in a way. So of course, there are certain standards that needs to be put across to protect the data that is being transferred from one point to the other. So when you hear of the computer networks, first, the concentration should be on the fact that it's a collection of devices. And in that case, the devices could be computers, servers, routers, switches, and so on, that are connected to facilitate communication and also information sharing. And I also said that any device that is on the network is termed as a node. So if you have a computer on a network, it's a node. If you have your phone on a network, the phone is served as a node. If there is a printer which is on a network, the printer would be classified as a node, N-O-D-E. Devices connect via wired or wireless. So when we set up a network, how do these devices communicate? And they communicate through this medium, either the wired medium or the Wi-Fi medium or wireless medium. For the wireless medium, we have the Wi-Fi and also Bluetooth. Of course, it goes beyond this. But basically, when you hear of the computer networks, these key things should run into your mind. Now, there are different types of computer networks, which we are going to talk about all these. These are things that we're going to talk about. We have the local area network, the wide area network, and in there, the local most of the time is centered on a small area. The wide, as the name says, span at large geographical areas like the cities and also the country. We'll talk about key communication protocols which have been outlined here. We'll talk about security, importance of all networking in modern day life. So the key protocols which we normally use for networking is the TCP/IP, the HTTP, and also the FTP, which is the file transfer protocol. It enables us to share files. In terms of security, we use authentication and also encryption to protect sensitive data that needs to move from one point to the other. And by preventing unauthorized access, network security has the ability to do that. Of course, the importance of networking in our modern life has been outlined over here. Now, this is the overview of the computer network that we're going to talk about. Now, let's talk about the application of the computer networks. So over here, we have highlighted 9 key applications where computer networks, can be found. So computer networks have, in our part of the world, or virtually everywhere, has become integral in various aspects of our lives and other professional environments. In that, they enable enhanced communication. And by enabling enhanced communication, this enables or allows people across the globe to connect effortlessly through emails, messaging, and also video conferencing. So as an application of the computer network, we have the enhanced communication. And by enhanced communication, people from all walks of life are able to communicate effortlessly through emails, messaging, video conferencing, and so on. Now, networking itself also supports resource sharing. By resource sharing, we are able to reduce the costs by allowing multiple users to share devices like printer and also storage system. So I gave an analogy that if in a room there are, let's say, computers, and the computers are being used by individual humans. Now, each of these, in just one room, there are 100 computers. We want to, now you are the CEO of this company with these employees. Will it be appropriate to buy printer for the entire, for each computer that is in the room? So there are 100 computers. Should we, as a CEO, do you think it is best to buy an equivalent 100 printers to make it easier for each computer to print? This is a question to one of you. Anyone? Anyone?
Please come again.
All right. What I'm saying is, we just talked about, we are saying that networking helps in resource sharing. And I'm giving an example that we have, assuming you are, any of you is a CEO, and there are, let's say, 100 laptops in the room being used by 100 employees. Now, each employee would have to have access to printing. So as a CEO, would you recommend buying 100 printers for every employee using their respective laptops?
No, sir.
Why would you say no? Why do you say no?
Sir, it will cost much if you have to do it that way. But you can get one and connect all the laptops to it.
Yes, that is right, Blessing. So ideally, it would be best to have just one printer being purchased and connected on a network. So that is one reason why or one application of computer network. We do networking mainly because we want to share resources. And by saying this, and that is what I was saying, that the network also supports resource sharing. And it does this by enabling organizations to reduce costs by allowing multiple users to share devices like storing video. Sometimes it's not only about printers. You can have about, let's say, 10 terabytes of hard disks being placed on the network. And all employees, about all these 100 employees, can now save their files to this terabytes hard disks. So that is about resource sharing. And also file storage system sharing too as well. So collaboration is also very key over here. And when we talk of collaboration, it's streamlined with file sharing. While online gaming brings people together from different corners of the world for interactive entertainment. So virtually, online games, people are able to play. You might be here. I'm sure some of you play games with people who are not in Ghana, but somewhere else in maybe in different countries. So collaboration is streamlined with file sharing, in this case, in a game. Online gaming brings people together from different corners of the world for interactive entertainment. When we talk of, when we're in the area of businesses, for instance, we can have a network drive, a network that is set up to drive the growth of the e-commerce, opening new markets and also opportunities for selling products and also online. That is also another application. When we talk about a remote access, in this case, employees can efficiently, from anywhere they are, work at their convenience. So we have this, they will efficiently be able to work at their convenience wherever they are in the world. There is some sort of enhanced flexibility and also productivity when it comes to remote access to some of resources that are not stationed at where the employees are. In the area of education, we can have networks being provided to students for them to the vast resources and collaborative tools. And by giving them access to this, it makes learning more accessible and also interactive. When we talk about telemedicine, most of the time, telemedicine, there is medicine and there is telemedicine. So in this case, it's most telemedicine in itself is powered by networks. So without a computer network being set up, there is no way we can have telemedicine. Telemedicine could be where you can have a doctor maybe situated somewhere in Kumasi and a patient is in Accra and will have maybe an interaction with the doctor via a computer network, be in Zoom or FaceTime or whichever one. And the patient will be able to now tell the doctor what he feels, what is wrong with her, and all of that for diagnosis to be made. So telemedicine in itself is actually being powered by networks. And in this case, it ensures that medical care can reach millions of people, irrespective of where they are. If they are at remote areas, maybe there is war happening at any point in a country, and the doctor is unable to go there. They can fall on telemedicine to provide medical care to patients in these war countries. The final one, which is the Internet of Things. So virtually, we have Internet of Things, happening everywhere. And this demonstrates how networks are enabling smart homes, cities, and devices by enhancing convenience and also connectivity in our everyday life. So in this case, we can have maybe your lighting system at home being monitored, or even your camera at home, and you'll be in the office, you have the chance. IoT gives you access to now operate, go onto your devices that are home, put them on, put them off, view what is happening in real time, and so on. And all this is possible because of computer networks. So these are some basic application of the computer networks. Now let's talk about the classification of computer networks. So whenever we hear of classification of computer networks, we are actually breaking it down to the fundamental criteria for classifying networks. So these includes, we have the geographical span, we have the network interconnectivity, network administration, and network architecture. We will talk about each one of them into details, but in the meantime, let me briefly go through this. On the geographical span, it defines the physical scope of the network from local to global. So in this case, as the name says, geographical span. Our concentration is the physical scope of the network from our local network to a global network. For network interconnectivity, as you see here, it describes the structural design of the connection between the devices. So the first one is more centered on the network, from the local to the global. The network interconnectivity is by way of its importance is the structural design of the connection between the devices. Network administration refers to how the network is being managed and also controlled. And the final, which is the network architecture, focuses on the design and the organization of the network system itself. So this is the design of the network itself. This is responsible for the management and also the controlling of the network. This is responsible for the structural design of the connection between the devices. And finally, this is centered on the physical scope of the network, be it local or global. Now, let's talk about each of them one by one. So, when we talk of the geographical span of networks, which is the first one under the category or classification of the network, it gives this is with this the importance is to show us how networks are categorized based on their geographical span. So from the smallest to the global reach of the network. So from the smallest to the highest. So as arranged in this order, we have the PAN, the LAN, the MAN, the WAN, and the GAN. Now for the PAN, that is the personal area network. So the PAN are typically used for short range communication. And most of the time, what we normally use is the Bluetooth. So for instance, amongst you, if you are maybe in a room, you'll be able to send maybe a picture to a friend. Within this short range, there can be some sort of connectivity happening. So for the PAN, it's centered on short range communication. And most times, what we normally use for the personal area network is the Bluetooth. Now, when we move on to the next, because I said we are moving from the smallest range to the highest. When we move on to the next one, which is the local area network, which we normally tell as the LAN, they are commonly found at homes, offices, and also schools. And it does this by providing network connectivity within a building. So in maybe at the administration of GCTU, the building on its own. So a local area network could be set up where all the devices can be put together, connected together for the transfer or the sharing of resources. So that is the local area network. So it covers an entire building using intermediate devices to connect different floors. So you can have about 6-story building in one location. Opposite it is another 6-story building. Opposite, adjacent to it could be another 6-story building. So each story building would have a local area network. And when we combine them, all the 3-story buildings that I just talked about, we can still have a local area network. Because in terms of geographical location, we are virtually on the same premise. So we can't classify it as a metropolitan wide area network. It's still going to be a local area network. So the buildings that you have in GCTU, each building will have a local area network. Then when we connect all of them together, we still have a local area network. Now I heard, I'm told GCTU has another campus. So if that campus is far away, then we can have the metropolitan area network, and that spans across a whole city, connecting different locations within it. So in that case, whenever you think of MAN, it is used to connect networks across cities. And most times it is being used by the ISP or large enterprises. The internet service providers are the ones that normally use the MAN. We also have the WAN, which is the wide area network. And the WANs can cover broader. So, and such areas can have multiple cities or even countries being set up in a way that we could have a public or a private telecommunication infrastructure being there. So for one, it connect devices across multiple cities, provinces, or regions. Sometimes it could even be countries. Then we have the final one, which is the GAN, which is which the GANs, which are normally used for global communication, and typically it involves satellites and a sea cable connecting continents. So that is it. So each of these types has its specific use case, and this is mainly based on the scale of connectivity that is required. So these are the, when we talk of the geographical span of networks, these are what you should have in mind. And graphically or pictorially, this is how it's being represented. For the pan, we could set up a Bluetooth here, or we could also have a wire, the computer can share its wireless to these devices and we can have a short communication with this. But most times we normally use the Bluetooth. So we can have a Bluetooth mouse connected to the computer, mobile phone Bluetooth, a printer Bluetooth, and so on. All these things will fall under the PAN, which is the personal area network. Now we talked about the other one, which is the local area network. So for the local area network, we can have we have a network in here. This is a server, and we have, it is assumed there is a switch somewhere. The last time we spoke about switches, hubs, and so on. So it's assumed that there's a switch somewhere here where we have these devices connected to it, and the entire server also connected to the switch. So in this case, we can have a server, and all these devices can now talk to the server. So this could be a local area network. So these computers can be on the first floor, this can be on the second floor, the server can be on the ground floor, the printer can also be maybe at a place, another floor, to set up a local area network. Now for the metropolitan area network, we can have the office building over here, as I talked about. You can see we have maybe one office building here at GCTU, another here, another here, another here. All these ones will serve as a local area network. We can have a university campus network set up here, and a government building also set up here, and so on. So each of these are local area network based on their location, and all these can be put together. If they are the same metropolitan, we can put them together as a metropolitan area network. And as we said, metropolitan area network is spans cities and so on, and provinces and so on. So this is a metropolitan area network that is being set up. And this is the wide area network. So we can have primary sites, we can have, with the wide area network, we said it can also span cities, province, and or regions, or sometimes it can even be countries. So that is about the wide area network. It goes beyond the metropolitan area network. And the global area network. Yeah, Blessing. Blessing, your hand is up.
Yes, sir. Sir, please, with the metropolitan area network, that one, is it that all of them are having one server, or they all have their service? Are they having one particular server, or they all have service? He said it's comprised of the local area network that is being joined together.
Yes. Okay, so now let me go to let me use this one as an example. So for every, let's say this is a university campus. A server is just to serve so many nodes on the network. So a server can just be a computer that has huge capability of serving other computers. Now, we can have one server over here. Okay, let me use this. This is Tesano GCTU, assuming this is Tesano GCTU campus, and this is at GCTU maybe in Takrady. Okay, so now GCTU Tesano here can be the main campus. We can have one server only stationed here that is controlling the entire student's record. So if you want to check your grades, you want to check your fees, you want to register for your courses, that server could be on the main campus. Now, there is another campus, maybe in Takrady. In the Takrady campus, of course, all students can be routed to this Accra campus to do their online registration for every semester. So in this case, there is no need to have a server in here. The server is just a device to serve so many people. But assuming there is a special maybe program that is being taught in Takrady, but not in the main campus, GCTU can set up, can have a local area network there with a server in here. And in this case, the server will be mainly for people that are in Takrady, serving them. So each of these, this will be a local area network in Takrady, another local area network in possibly the main campus, different local area network. So the local area network does not, whatever device you put on it, you can put any device on it. You could put so many servers on it. You could put so many computers on it. It doesn't mean that you should have one server only at GCT. You can have a server here, another server here, another server here, depending on your network architecture or the kind of files or data that you want to transmit to everybody. Or GCTU can have its main server here, and all these campuses can now connect to this main service here on premise to have to do their registration and so on. The server is not a network, it's just a device on the network. I don't know if I'm okay. Blessing, are you okay?
Yes, sir. Thank you.
So the server is just any device, it's a node which is on the network. So that is one thing you should be mindful of. It's just like, let's say Facebook. Facebook is in US. Possibly their server is also in US, but we are all connected to it. But globally, we all come together to form the global area network. Let me put it that way. But of course, that does not mean that we can also have our server in Ghana. That is helping us maybe doing national health insurance scheme and all of that. So every local area network could have a server that is serving devices that are on that particular network. All right, so for the GAN, which is the global area network, the concentration is all of these wide area network coming together. And eventually, of course, the GAN is used for global communication. And most times we normally think of using satellite or using undersea cables to do the connection between continents and so on and so forth. But of course, when you put all these things, they all come together to form the internet. Right. Now let's talk about the next one, which is the network interconnectivity. The first one was the geographical span of networks, which is under the network classification. So let's talk about the network interconnectivity. Now, this explains different ways that network devices can be connected based on their design and also their structure. So sometimes we will say network topology. It relates to that in a way. So when you hear of the network interconnectivity, the concentration is also on different ways by which network devices can be interconnected based on their design and structure. And based on that, we have these types of structures that exist. So for a mesh structure, every device is directly connected to every other device. And in this case, it does so by maximum redundancy, but requiring more cables and also management. So under network interconnectivity, under that, the type which is called the mesh structure. When we talk of network topology, I think I'll break it down. You will get it. The mesh structure, the concentration is that every device is connected to every other device on the network. And it does so by maximizing redundancy. So for instance, we can have a server connected to maybe one local area network, another server connected to the same server connected to a different area network. Or better still, let me put it this way. The ICT units or the data center at GCTU, maybe GCTU has two ISP, one from Vodafone or Telecel, and one from, let's say, MTN. So, and so Vodafone gives GCTU internet access. MTN also does the same thing. Now, we can set up a mesh structure in this case so that in case Vodafone goes off, MTN will be on to serve the nodes on the network with internet access. So with a mesh structure, every device is connected to every other device. And it does this by offering maximum redundancy. So if there is one of the network down, it does not stop communication of the other nodes on the network. But this type of architecture or structure is quite expensive because you'll be requiring more cables and also more management to be able to manage this particular type of structure for mesh topology or mesh structure. Now we also have the bus structure. With the bus structure, all the devices are connected to a single shared communication medium, often used in old networks like the Ethernet. So the bus, we normally don't really use it in our current network topologies or structures, but it has, of course, it does have some limitation as the number of devices increases. So we have just one of which all the devices are connected to a single medium. So the transmission medium is just one. With the mesh, you can have so many mediums given access to these nodes to be on the network. We also have the linear structure, which creates a simple connection where each device communicates only with its immediate neighbor. And it does so by forming a chain. So this linear structure is similar to the ring topology. We have the star structure too as well. And most times, most of the modern networks use this particular structure, which is the star structure. And in this case, all the devices connect to a central device. Most of that is centered on what we call the hub or the switch. The hub, I told you the difference between the hub and the switch. So there's a difference with this. So for a star structure, virtually all the modern computer networks use the star structure, mainly because it provides ease management and also fault isolation. So if all the devices on the network, which is the node, if all of them are connected to, let's say, the switch or the hub, of course, when one of the other devices can work. It's when the hub goes down or the switch goes down, that is when it becomes a problem for the other devices to have access. The hybrid structure, as the name says, hybrid, combines elements of the multiple designs, which is tailored to meet specific network requirements. So with a hybrid, it can combine all the various structures that we have with devices connected in multiple ways. So that is about the network interconnectivity and the types that exist in there. The next one is the network administration. And this covers the distinction between the private and public networks from the perspective of network administration. And in this case, there are two main types. We have the private network and also the public network. So for the private network, it is typically owned by an organization. and it is confined within its own boundaries, doesn't go anywhere else. So GCTU can set up a private network solely in GCTU, and it doesn't, if you are not connected to GCTU network, you will not have access to that particular network. So that is an example. So typically owned by an organization, and it is confined within its own boundaries. So maybe Flaster would have their private network. So most times, network administrators, when they set network, the local area network that they normally set up, which is not connected onto the internet, will serve as a private network. So the IPs that are given are all private IPs that is stationed on premise, doesn't go anywhere. So, and most times, if you want to access these private networks, there is some restriction to that. And it cannot be reached from the outside world without proper authorization or the use of the private virtual private network, which we term as a VPN. So if you want to come into such a private network, you will need to have some authorization access or login credentials by using a private, a virtual private network or a VPN to tunnel through to that particular private network. So examples usually include internal corporate networks or intranets. All right. We also have the public network. And with the public network, of course, it's the other way around compared to the private network. With the public network, it's accessible to anyone. So the most common example of public network that we have is the internet. And in this case, anyone with the appropriate hardware, like a laptop, computer, mobile phone, can connect and have access to resources that are not on premise, but those resources can be online wherever. It could be at different locations, not necessarily where the person is actually having access to the internet. So that is a public network. So as you move on, you get to realize that for private networks, most of them are localized. So people outside are unable to have access to it. But the public network, we normally put up those IPs on a public domain where anybody can have access to it. And most times the ISP, for instance, Vodafone has given GCTU public IP addresses. And those public IP addresses are accessible wherever in the world. So, and those public IP addresses are the ones that possibly you are using for online registration. So the server can be stationed on campus, and that server will be given a public IP address. And the public IP address is accessible worldwide. So in this case, the server can be configured in a way that you can have maybe studentportal.gctu.edu.gh. That domain name can be linked to that public IP so that wherever you are in the world, you will be able to have access. But of course, if you are using a private IP, you will not be able to access it unless you are on premise. Right. So let's talk about the network architecture itself too as well. So generally, or most of the time, the network architecture serves as the blueprint of how the computer network is structured and how data flows between the devices that are on the network. And most times it involves both the hardware components, then the example of such hardware components, routers, switches, and the servers, and also the software systems, which also includes the protocols, which is being used for communication. So basically, there are two primary types of network architecture, and these are the ones that are been highlighted over here. We have the client-server architecture and the peer-to-peer or P2P architecture. So let's talk about each one of them. So for the P2P, which is termed as a peer-to-peer architecture, it's an architecture, it has a network model. And in this case, each of the node, which is the device of the network, can act as both a client and also a server. So in this case, unlike the traditional client-server systems, there is no central server controlling the network, but rather we have a communication that occurs directly through nodes. So peer-to-peer, so P2P architecture itself is a network model, and it allows nodes to act as both client and server with no central server controlling the communication. Those that have used software like BitTorrent, Bitcoin, and the concentration is on this one. Those that torrent, torrent is a P2P, works on a P2P architecture. So when you download a torrent file from the torrent site and you launch it through maybe BitTorrent or uTorrent or microtorrent, the moment you launch it, now the torrent file has some details to connect to devices that have the files that you're looking for. So the moment you launch it, it looks for P2P. So if what it does is you launch the application, it goes on the network to find. Let me explain it this way. I want to download a file which is maybe Microsoft Office 2021. I have been able to torrent it on my computer. So if another person wants to torrent it, the file is able to connect to any device which is on the network that has the file that I'm looking for and tag himself. The device will tag itself to that particular device to download the file directly from the device that has the Office 2021 that I'm talking about. I don't know if I'm making sense over here. Are you hearing me? Can you hear me?
Yes, sir.
Yes, sir, we can hear you.
All right. So just like as I said, I'm looking for a software, Microsoft Office 2021. I go online, I download a torrent for it, I launch the BitTorrent software. And the BitTorrent software now looks for devices on the entire network to find out if anybody has the Office 2021. Then connects to that device and now pull the download for me. So at any point in time, if on my computer I have the Office 2021, my computer can now serve as a server to another person who is looking for the Office 2021 and it will serve as a server to give access to that file that is on my computer. So in that case, that's computer that is looking for the file becomes a client. So that is how the P2P architecture works. There are some key in the P2P network, and these are what has been outlined in here. We have this decentralization, and the emphasis is on this is there is no central server or authority. So if one node fails, the rest of the network can continue to function. So this makes P2P network resilient. So if your computer has it, and at the end of the day, another computer does not have it, another computer has it, and mine goes off, it falls on the other computer that have the file that I'm looking for to download. So there's some sort of decentralization. In this case, there is no central server or authority to now manage the network. but to manage the files that are being transmitted to individual nodes on the network. Now, in terms of resource sharing, a P2P also allows nodes to share resources like file storage and also computing power. It's when Bitcoin comes in. Those of you who have been visiting some websites, without your knowledge, sometimes you might have files being downloaded on your computer where people might be using your computer resources to be mining Bitcoin. So let us be careful where we go. So there are times your PC is a gaming PC or a very good PC, but at the end of the day, it's always very slow. It's because sometimes you probably visited a website and that website installed a bot on your computer and is being controlled by somebody who is not possibly in Ghana and now using your computer resources to mine Bitcoin for himself. So there are software like Cryptus that is being used to mine Bitcoin. I think some of you can check it out. So if you have a very good computer with very good GPU as a graphic processing unit, not CPU, but GPU, a good GPU, like the gaming computers, instead of using it to play games, as a place where there is internet access, use a software called Cryptex, KRY PTEX. Use it to mine Bitcoin. And in a day, you probably will be making between $4 to, let's say, $10 every day. So imagine running something like this for an entire month. Can imagine how much you make. So those people that have very good computers, they are just using it for playing games. It's best to use it to mine Bitcoin. Anyway, that was just by the way. Right, so resource sharing, P2P allow nodes to share resources like file storage and computing power. And this ability is useful for distributing large files or for tasks requiring distributed computing. I think most of the telcos, they normally have shared resources when it comes to share network resources or maybe the resources of a computer to perform other function. And this could be done by using virtual machines or virtualization of the computer itself. Now, in terms of scalability, the network can grow by simply adding more nodes. And this will make the P2P system highly scalable with minimum changes required. So this is another key characteristic of a P2P architecture. Finally, security. With no central server, P2P can be more secure since there is no single point of failure on the network. But in this case, there is one thing that we should be mindful of. May be very vulnerable. If the file that is being transmitted contains virus, you can imagine that, of course, the device will be compromised. So examples of P2P networks include file sharing services like Bitcoin, so BitTorrent, instant messaging platforms like Skype, and cryptocurrency systems like Bitcoin. So in spite of all these advantages, P2P networks can have some drawbacks, and this includes challenges in managing and securing any of the nodes that is connected to it. And in this case, in terms of performance, a node's performance can be reduced, and you will have the nodes possibly crashing or not being able to perform at its optimum speed or maximum performance. All right. But of course, people still believe that P2P remains an important network architecture, especially for file sharing and also decentralized systems. So that is one of the architecture that exists for computer network architecture in terms of the type. The next one, which is the client server architecture. I think we briefly talked about it the last time. It is widely used by most organizations, and it is normally used for network for clients devices such as computers, smartphones, and so on. And in this case, this particular network model will have the client devices, and these client devices rather request for services from the server devices. And it's the server devices that provide resources to the client devices. So in this architecture, the servers are responsible for hosting the resources itself. And these resources could be the application, it could be files, it could be a database, and the clients will have to place a request to access these resources via the network. So these are some key characteristics of the client server architecture. So centralization, specialization, scalability, and security. It's just similar to the other one. When we talk of the centralization, the emphasis is that the servers itself are responsible for managing and controlling access to the resources and the services on the network. And it does so by streamlining the process. So everything is centralized. It's the server which is doing all these control, managing of the resources and so on. Now, in terms of specialization, the servers in the client-server architecture model are typically specialized to handle some specific tasks. So an instance could be some servers being used to manage only emails. We could also have other servers being able to manage only web hosting and others databases. So most of these for client-server architecture, the servers are specialized. They are mainly meant to do something. If it's a web server, then it means it is performing a function of a website and serving clients with web services. The server too, it is doing the same thing and so on. In terms of scalability means the ability to now increase maybe its functionality. So the system can scale efficiently. In this case, you can add more clients to access the services that is being provided by the server, and also add more servers to also increase the system's capability. For security, the client-server architecture itself has the ability to offer better security since most of the access to the resources is controlled by the server itself. So if it doesn't grant access to the clients coming in for that request, it's a way of securing the server from being hacked and so on. So security-wise, this is also very good. So these are some examples of the client's server architecture: the email service, web service, and the database service. So in spite of the fact that this architecture offers central controls, better security, and also scalability, it can be more complex and closely, and sometimes it's very expensive, to set up a server for, so many clients coming in. Those of you who are into web development or websites design, when you are buying a domain name together with a hosted platform, you have to be very careful. You should have a knowledge in the bandwidth that is going to be given to that particular server. If not, your PCs will be crashing at any point in time. When you have so many clients connecting to your computer or your server or your website, you might experience something like bandwidth exceeded. So these are some key things that you should be considering whenever you're thinking of buying hosted environments for web services. But of course, it also comes with a cost. If you want better services, then it means you have to pump in more money to be able to, serve so many clients. The last one, which is the data transmission. I think we've talked about all of them, all the three. Finish the network administration, network architecture. So let's move on to data transmission signals. I'm hoping to finish this lecture quickly. Yeah, so as the name says, data transmission signals. We are continuing with the signals from. So DTS, or data transmission signals, are used to carry information from one device to another, and typically over physical medium such as copper wire, fiber optic cables, or wireless transmission. So those are the transmission medium that exists for data transmission. So these signals can either be electrical or electromagnetic. And most of the time, it depends on the transmission medium and the requirements of that particular communication medium. So before data is transmitted by a medium, it must first be converted into electromagnetic signal or electrical signal. So let me put it this way. So for us to be able to transmit data from one point to the other, data could be voice, it could be anything. First of all, it must be converted into electromagnetic signal. So these data signals can either be represented in form of analog signals or also digital signal. For analog signal, an example could be my voice coming in here. So the data that is being transmitted, which is converted into electromagnetic signal, in my case, would be analog signal, which is represented by my voice, or digital signal, which could be a file which is stored on a computer. So both the analog and the digital data can be represented using either digital or analog signals. So generally, there are two main types of data transmission signals. And these are the ones that have been outlined here, the digital signal and also the analog signal. Digital, something that has got to do with zeros and ones. Computer does not understand anything apart from zeros and ones. So for digital signals, these are discrete signals that are represented by binary digits in terms of bits, which can only be zeros and ones. And again, we can also say that digital signals are more resistant to noise and interferences than the analog signal. We talked about some of these things in our previous lecture. So for analog signals too as well, these signals are continuous, varying in amplitude and also frequency over time. An example was for analog signal, could also be the sound waves and the radio waves casted for us to use. But of course, although it's a continuous signal, it also has some cones. They go to interferences and noise. So in terms of choice, the choice between the digital and the analog transmission depends on the specific needs of that particular communication. So, and the choice could be centered on distance, speed, and also the environment in which the transmission is going to be transmitted. If you are laying cables from one building to the other, you ask yourself, are you going to use a fiber optic cable or are you going to use the radio waves wireless to send the signal? It depends on the type of data that you are transmitting. And that will inform your decision to make a decision which application or which medium or signal you would want to use to transmit that particular data. Now, when we talk of transmission impairment, on your screen, you can see that transmission impairment itself normally occurs when a signal degrades. So as impairment, just like when we say someone is visually impaired. So in transmission impairments, it normally happens when a signal degrades or distorts as it travels from the sender to the receiver. So as the signal moves from one point to the other, if there is a degradation on the signal or there's some sort of distortion, then we'll classify it under transmission impairment. And in this case, this particular degradation can lead to loss of data integrity or slow communication speed. And the following that has been outlined here are common causes of transmission impairments. We have attenuation, dispersion, delay, distortion, and also noise. I've explained attenuation, I explained it the last time, but I'm going to reiterate. So as the signal travels for attenuation, as the signal travels, its strength diminishes. You remember I said that the Cat6 cable or the Cat5e cable, that is a regular cable that we use to connect to our computer. After 100 meters, the signal reduces and drops. So you need a repeater to boost the network. The repeater could be in the form of a switch. Sometimes you can use a hub and so on. I showed you pictures of repeaters in previous lectures. So attenuation will fall as one of the causes of the transmission impairment. After 100 meters of using Cat6 cable and 5 cable, attenuation sets in, and when it sets in, it means there's a loss in signal. If there's a loss in signal, we need a device to now repeat the signal or boost the signal so that other devices that are beyond the 100 meters will also have access to the signal. So the attenuation itself sets in when we have long distances coming in and using a cable, a regular cable to do that. So that is for Cat6. After 100 meters, it goes down. Fiber optic cable also has its limitation, just like how we have when we use Bluetooth or wireless. The wireless that is mounted in one building might not be able to probe that particular wireless signal when you are far away from that signal. So that is about attenuation. So over long distances, the signal becomes weak and it may become too weak to be interpreted by the receiver. So the receiver will not be able to see what you are trying to send to him. I'm talking about send to the node. So in that case, you need repeaters or amplifiers to boost the signal all over again. So that is about attenuation. Now we also have one we call the dispersion, which is one of the causes of transmission impairments. And whenever you hear of dispersion, what should drop in your mind is when a signal travels through a medium and it may spread out and overlap. So in this case, this effect can distort the signal and often, and most times this is dependent on the frequency of through which the signal is being transmitted. You know, sometimes when you are, I don't know if any of you have used any of the wireless devices or configured any of the wireless network devices. During the configuration process, there is a channel that you have the option to choose the channel through which you want to broadcast the signal. So if one device is broadcasting at a signal on channel 6, and there's another device broadcasting on the same channel, you can see some sort of dispersion going to happen on that particular network. So with dispersion, when a signal travels through that particular medium, most times the wireless, it may spread up and overlap with other signals in the same channel. So this effect will virtually distort the signal. And most times, it's the frequency of which the signal is being transmitted over. Now we have the delay distortion. And in this case, we have different components of a signal coming together to travel at different speed or frequency. And sometimes, because of that, they cause some sort of bits to be arrived before the others, which can result in loss of synchronization. And this normally is typical or critical in digital communication. That is a delay distortion. So with the delay distortion, the emphasis is on different components of the signals being traveled at different speed or frequency. If they are traveling at different speed and frequency, there's a high probability that this can cause some bits to arrive before the others. And if it does arrive before the others, of course, you can imagine what will happen. The results would have a loss of synchronization. All right, so that is the delay distortion. And finally, we have the noise, which is also categorized into four. But generally, the noise itself refers to unwanted random disturbances. I think we talked about this the last time in a signal, and most times it would alter or it will degrade the transmitted data. There are different types of noise that are available. You have the thermal noise, the intermodulation, the crosstalk, and finally the impulse noise. Now, each of them have unique features. So in this case, for the thermal noise, it's normally thermal has got to do with something hot. So thermal noise is caused by heat affecting the medium. This type of noise is inevitable. So that setup network cables. Usually, you are advised not to run the network cable a little different from not the same path, using the same channel as your electrical cables for buildings. There should be some little space between them. Anyway, of course, if you are using network cables, regular network cables, in terms of the physical cables, and these cables are being heated, you can imagine some sort of noise being introduced into the transmission of the data through the signal. So for the terminal noise, the emphasis is we have heat causing or affecting that particular medium. And by so doing, there's noise that will be incorporated or that will be added to the signal that is being transmitted. For intermodulation, it normally occurs when we have multiple frequency interacting and also interfering with unwanted noises. Intermodulation. So occurs when multiple frequency interfere or interact with a signal, and this will lead to unwanted noise. For crosstalks, it also happens when a signal from one medium interferes with another medium. And of course, if it does, a signal from one medium goes into another medium, it will cause unwanted noise in the signal transmission. And finally, the impulse noise is caused by irregular disturbance such as lightning, power surge, or faulty components, which is particularly a problem when it comes to digital signals. So these are the causes of transmission impairments. There are four main causes: attenuation, dispersion, delay, distortion, and noise. And for noise, these are the types that exist. Finally, we have some techniques that we can use to mitigate some of these transmission impairments. So when we use high quality transmission media like fiber optic cables, and we also try to also employ technologies such as amplifiers and repeaters and digital signals processing in doing or dealings, transmission impairments can be minimized. We will be able to reduce it in a way. And when we do reduce it, it will ensure reliable data communication. Just a minute, please.
Hello, sir. Hello.
Oh, sorry. I received a call. I had to pick the call. Sorry about that. So that is about transmission impairments. So let's talk about the network criteria. Um, please hold on for a second. I'll be with you shortly, just about 2 minutes. Yes, sorry, I'm back again. Yes, so let's talk about the network criteria. So when you hear of network criteria, these factors are very important. And when you think of network criteria, and of course, whenever you are designing and also maintaining a network, you make provision for these factors, the performance, the reliability, and also the security. Now, network criteria itself refers to the key characteristics that are essential in evaluating the performance and effectiveness of the computer network itself. So the key characteristics that are so important to help in evaluating the performance and also the effectiveness of the network is what we term as the network criteria. So in this case, whenever we are designing and maintaining a network, the following factors are critical: the performance, the reliability, and also the security. In terms of the performance, it is the key indicator for the network's ability to function effectively. And in this case, it can be measured in terms of transmit time, the response time, and also the metrics, or the metrics, yeah. So these are things that you should have in mind. So in terms of the transmit time, it's a time it takes for a message to travel from one device to the other. So the time for the message to travel between the devices is a transmit time. But for the response time, it's also the time which elapses between the inquiry and the response from the network. So during the time that an inquiry is made and the time the response is being sent, that is the response time. And we also have the matrices. In terms of the matrices, there are two important matrices for measuring the network performance. And these are the throughput and also the delay. These two matrices are very important. Those of you who do your final year projects, when you start with a degree program, when you come out with some of your research in networking, yeah, it's important to include throughput and also the delay in your network analysis. It's very key in here. And when we talk of the throughput, which is another metric, the throughput is more centered on how much data is successfully transmitted in a given period. And finally, the delay itself, the amount of time it takes for the data to move from one sender to the recipient. So these three measures are important or critical whenever you think of performance in network criteria. the transmit time, some will say transmission time. We have the response time and also the matrices, which involves the throughput and also the delay. The throughput is how much data is successfully transmitted in a given period, and the delay is the amount of time it takes for the network to move from the sender to the for the data to move from the sender and also to the recipient or the receiver of the message that is being sent. For reliability, the concentration is on frequency, recovery time, and also network robustness. Reliability in itself refers to the network's ability to function consistently and recover from failure. So if we say somebody is reliable, it means we can count on that person. So in this case, the network criteria to when we say the network is reliable or has a reliability property or factor, then it means this network has the ability to function consistently. And if there is even any failure in it, it's able to recover from that failure to provide consistent availability to clients or devices that are on that particular network. So in this case, it's most of the time measured by the frequency of the failure, the recovery time, and also the network robustness. In terms of the frequency of the failure, it gives us knowledge on how often a network experiences disruption. For recovery time, it's how long it takes for the network to recover after it has failed, after there is some sort of failure on the network. The network robustness is how the network can handle and also adapt to any failure or catastrophic failure or unexpected events. So that is about the network robustness. So all these things, these attributes falls under the reliability of the network. And finally, for security, when we talk of the network security itself, the emphasis is the network should be able to protect all devices or nodes from unauthorized access, misuse, and also modification of data across the network. So for network security, the emphasis is that that network should be able to protect the devices of the network from unauthorized access, modification, and any sort of misuse of that particular network. And most times, it involves the implementation of policies and also provision of safeguard measures that will be put in place to prevent unauthorized access to such resources. In this particular case, of course, we put up something we call access control list, or we have a list or a list of devices that should have access to the network. It's not anybody that would have, or any node that is on the network that should have access to that particular network. So there are security strategies that are most of the time put in place to prevent unauthorized access on the network. So these criteria usually form fundamental for ensuring the network can efficiently meet the demands of the users or the nodes that are on the network, and also supports business operation while being secure and also resilient. So these three factors are very key when we think of network criteria. Now let's move on straight to the types of network connection. We have the point-to-point, and we have the points to multi-point. There are two main types of network connection: the point-to-point and the points to multi-point. So for point-to-point, in computer network itself, when we talk of the network connectivity, so these are devices that are connected through links that will facilitate data transmission. So there are two main types about of the network connections, and the point-to-point and also the multi-points. When we talk of the point-to-points, as has been outlined in bullets over here, this is type of connection that is mainly used to establish a direct communication between two devices, such as through a serial cable connecting to the computers or devices, the printer, and also the computer. So in this case, the main advantage of point-to-point connection is that they provide fast and efficient data transmission and low latency and high throughput. So for point-to-point, there is a data communication link between two devices. We have a fast and efficient. It is fast and efficient with no intermediate devices, as you can see from here, one device, another, direct connection to each of these nodes. An example, in this case, we normally use serial cable between two computers. And the benefit is we have low latency, high throughputs, and there is a high probability of securing the data being sent, being secure, because it's meant for these two devices. We don't have any third party or third node on the network to have access to that data. So these connections tend to be more secure in this case, mainly because we have fewer points where data can be intercepted, as you can see over here, but can be expensive due to the need for dedicated resources such as cables and these lines. In terms of flexibility, these ones are more flexible compared to the points to multi-points. So these are the limitations: expensive, less flexible, require dedicated resources. Now for the second one, which is the point to multi-points. So for a computer network, for the point to multi-points, in this case, as you can see from the diagram here, we have shared communication link among multiple devices. So there's a communication link which is being shared to multiple devices. So there is wireless devices connecting to an access point. I explained the difference between routers, access points. Access point, we can have an access point which is wireless. Access point just give you access to the main connection. So as an example, the wireless network with devices connected to an access point would be an example over here. In terms of benefits, flexible, cost-effective, allow communication between multiple devices. And the limitation we have potential for interference. For the first one, which is this one, the points to points, connection is directly from here to here. It will be via a serial cable or a regular network cable. It's from directly to two devices. So there is no other device to eavesdrop data that is being connected on the net, that is being transmitted on the network. Now with this one, there's a high probability another device might have access to the data by eavesdropping on the data that is being sent from one point to the other, because the linkage is not to the individual devices, but rather to a stream of devices. So there is a potential interference, congestion, and also reduced security. In terms of congestion, if the network is not robust enough and all these devices are transmitting and receiving data concurrently, there's a high probability you might have a congestion on the network. So that is what we mean by that. So there are types of, still on types of the network standards. We have some standards that are important whenever we think of network connections or computer network in itself. So network standards itself are essential for ensuring that devices from different manufacturers can communicate and also function together in a network environment. So iPhone is providing network wireless. This is also doing the same thing. Other vendors are all producing their network devices. So in terms of interoperability or in terms of these devices that are being provided by different vendors, what is there to make it possible for somebody using Infinix to call on an iPhone and they will be able to communicate. So there are some standards, that is an analogy. So there are some specific standards that are being put in place that the manufacturers or vendors have knowledge of. So they always will stick to those standards when they are producing their devices. So when we talk of network standards, they are essential for ensuring that the devices from different manufacturers will be able to communicate and also function together in a network environment. So these standards can help create a competitive and open market by guaranteeing interoperability between the diverse technologies that exist, as I talked about. So there are several key organizations that are responsible for creating and also maintaining the network standards. And these are the organizations. So notable among these organizations are the ones that have been outlined in here. We have the ISO, which is the International Organization for Standardization, the IEEE, which is the Institute of Electrical and Electronics Engineers, IETF, which is the Internet Engineering Task Force. We have the ANSI and the SITS. All these organizations are responsible for creating and maintaining the network standards. So the manufacturers always stick to fall on these standards that have been created. The network as created by these organizations as network standards to produce their hardware and software to make it easier for different vendors to communicate with each other. So the network standard can be categorized in two main types. We have the de facto standards and also the de jure standards. So those are the two main network standards. By the de facto standards, as you can see here, these are standards that have not been officially approved by an organization, but rather have gained widespread adoption due to their popularity and also market share. So those are the de facto standards. So I'm going over again for the de facto standards. They have not been officially approved by any recognized organization. But of course, a lot of vendors have been using it over and over again. And because of that, they have gained widespread adoption by most of these markets. And because of that, because everybody is doing it, there has been in existence for a very long time, they become a de facto standard that is there. But of course, they have not been approved by any of these organizations responsible for the network standards. So an example is the TCP/IP and Microsoft's Windows. They are examples of de facto standards. And this is because they became the default in their respective areas in spite of not being ratified by the formal standard bodies. The TCP/IP has been in existence for a while. Microsoft Windows has been there. They were not actually being approved, but because they've been there for a long time, it is accepted, and people build their hardware and software around them to make it easier for deployment on such systems. For the de jure standards, these are official standards that have been legislated by recognized bodies like the ISO, or the IEEE. So these ones, they are officially have been approved and has been legislated by these bodies. So they are developed through formal processes, and usually it takes periodic audits and reviews before the approval does come. But of course, these standards ensure consistency and reliability across network technologies. So most of the new products that are coming, they always will stick with the jury standards because they are the ones that have been approved by the standards and organizations that are responsible for the network standards. So overall, all the network standards are important for creating and maintaining the efficiency and the scalability of the communication networks. And with this in mind, we are able to ensure that devices can now work together seamlessly and also irrespective of the manufacturer, the technology that is being put across, anybody can use that kind of technology. So for network, so that is about the network standards. Now, in the initial stages, I gave some brief knowledge about the network topology. I'm going to just hit on them quickly, then I think we'll be bringing the class to an end. Yes, we have the network topology, which is referred to the arrangement of various elements in a computer network. So anytime you hear of network topology, think of it as how the devices on the network have been arranged. B is the switches, B is the computers, B is the cable, all of them. How has it been arranged? So when you hear of network topology, think of the arrangement of the devices and the connection in a network. So in this case, these devices are the nodes. It could be the nodes, it could be the other hardware, the routers, the switches, and so on. They are devices that forms the network topology. There are basically two primary aspects of the topology. We have the physical topology and also we have the logical topology. So there are the two main types of network topology. The physical topology, as you can see, physical is the actual physical layout of the network. So in this case, devices that are used and the arrangement of the cables that connects to them will fall under the physical topology. So it refers to physical design, including the device's location, the cable installation. They all fall under the physical topology for the network topology. In terms of the logical topology, that is a little different from the physical, but the logical topology is meant for deals with how data flows within the network, irrespective of the physical setup. So in this case, the logical topology explains the data path, while the physical topology explains the hardware. So those are the two main types of network topology. Now, there are four main types of the basic network topologies that exist. So in terms of the basic network topology, there are four main types. We have the bus, the star, the ring, and also the mesh. You recall, I think some of these things when I talked about it, the bus structure, the star structure, and the others, the mesh structure. I was making emphasis to the topology too as well over here. So each of these topologies has its own advantage. Let's talk about each one of them quickly. Just bear with me, give me about 10 minutes, then we'll just go. So with the bus topology, this is how it looks like. So all the devices are connected to a single central cable. And this central cable is normally termed as the backbone. So this design makes it relatively easy to set up and maintain because there are fewer cables that will be required to connect to the network. And most of the devices that you see over here on the network are able to send and receive data through the backbone, which is this one. And each of the devices checks whether the data is for it or not. So you can see this on the backbone, and we have the tokenizer at the bottom where it is being terminated. So we have a termination of that. So although this is cost effective and simple, this type of topology, as you can see, although it's cost effective and simple, the bus topology itself has some significant, it has some issues. So if there is a central cable failure, the entire network will be disrupted. So if there is a cut over here, it means the cut for the backbone, then it means there is a problem. And the network grows, and as the network grows, we have more devices getting added to the backbone. The amount of traffic on the backbone will increase. And when it increases, there's a high problem that there may be a network congestion and the performance will be degraded. There will be some sort of degradation on the network in terms of performance. So the figure here explains this particular type of topology, which is the bus topology. Now let's move on to the next one quickly, which is the star topology. So in this type of topology, this one, I've explained these ones in earlier slides, but I just want to reiterate and more like a recap of this. Just 5-10 minutes, I'll just finish with you. So in the star topology, as you can see over here, all the devices, so this is an example of it. So the star topology, so all the devices is connected to a central hub, and this is the hub or the switch, which directs traffic between the devices. So this setup usually offers several key advantages over the other topology. Each of the devices have a dedicated connection to the hub. This connects to it, this connects to it, this connects to it. And by having a dedicated connection to this hub, it helps manage the traffic flow more effectively and reduce the chances of data collision. And again, one of the most important or significant benefits of the star topology is that it is reliable. So if one of the devices fails, if this one fails, all these ones can get connected. If this one fails, all these ones can still have access to the network. And again, the topology makes it easier to add or remove devices without affecting the other part of the network compared to the bus topology. And this contributes to the network flexibility. In spite of this, well, with these benefits, there are some limitations to the star topology. It does not come with a drawback, but the hub is a single point of failure. That is, it doesn't really come with a drawback, but this particular hub or the switch is a single point of failure. So if this device gets spoiled or get damaged, it means all these devices will not be able to have access to the network. So that is a single point of failure, which is a disadvantage for the star topology. So, and that's the diagram explains the disadvantage for the star topology. And finally, we also have the range topology. So with the range topology, yeah, in terms of characteristics and advantage and disadvantage, I'm going to combine them in the diagram. So with this, the range topology itself, you can see that the devices are arranged in a closed loop with each of the devices forwarding data to the next device. So this can forward data to this can forward data to this. So data travels in one direction along the ring, and each device helps to boost the signal, acting as a repeater. And in this case, this particular setup finds a way, is able to eliminate the possibility of data collision. So if data is supposed to flow in this direction, data will not flow in this direction. If it's supposed to flow in this direction, and if that is the setup for the this particular type of topology. That is how data is supposed to flow. So it will prevent data collision. And this is mainly because only one device can transmit data at any given time. And with the ring topology as an advantage, it reduces collision risks. The absence of a hub or a switch, the other one we had a switch, that is how come if the switch damages or the hub damages, it's affects the entire network. But in this case, if there is no hub or switch, so it helps reduce costs and also it simplifies the network. And there is no single point of failure for this particular network. But in spite of the good things, there is a drawback for this, and that is if one of the devices or the nodes or cable fails, if this one gets cut, the entire network can be disrupted. And again, adding or removing devices can be a challenge. It may cause interruption. You know, if you want to bring a new computer in here, it can be some sort of, it can cause some disruption on the network. So as the network grows and more devices are added, it is obvious that the signal will degrade, especially over long distances. So this is how the ring topology is. Now we have the mesh topology. The mesh combines all the other topologies. So you can see this is connected to this, this is connected to this is connected to that. So in terms of advantage, there is some sort of redundancy. You know, this router is connected to this, is connected to this, is connected to this. If this goes down, it has access to this router. So people here can still talk to other devices. So the mesh topology is one of the best topologies that exists. But unfortunately, it's also very expensive. So it's not every organization that has access to that. So that is about the mesh topology. Okay, so this brings us to the end of chapter 3, which is on network. And these are some questions that you should get yourself familiar with after we've done a discussion on all of these. All right, so thank you very much. I'll meet you, God willing, on Tuesday next week. You can take up the quiz. Our members, are you okay if we have the quiz on Friday? On chapter 2, solely on chapter 2.
Yes, sir. Friday.
Yes, sir.
Tuesday.
Yes, sir. Friday.
Friday
Tuesday,
is
please.
okay, sir.
Friday.
That is what time?
Okay, and if that is the case,
Said this Friday or next
Sir,
week
Friday.
no, this Friday.
Friday will be okay.
Hey, said
this
then
Friday will
next
be
week
okay.
Tuesday. Why? Sir, please, what time?
Okay, so you think about it. I'll talk to the other class. If it's
Okay, okay.
maybe on Sunday evening, so that then you take the quiz online, wherever you are.
Okay. Well noted,
Okay,
sir.
sir.
So I'll get back to you. Felix, get back to me again somewhere
Okay, sir.
later to find out consensus from you.
Thank you, sir.
Right, have a good afternoon.
Thank you,
Bye.
sir.
It's likely I might see you guys in 2 weeks after the election. I'll try and meet you guys in person. Right, bye-bye.